family and my dear friends. A very good morning to all of you.
Very great morning,
I
Aditi.
am Aditi of 11 B. Stand here for mastering the concept on subject chemistry and my topic name is equilibrium. From the chapter name, the question arises, what do you mean by equilibrium? Equilibrium can be defined as the state of a process in which measurable quantities such as temperature, concentration does not change with the passage of time. Now we'll study about the types of equilibrium. Equilibrium can be classified into two types, namely static equilibrium and dynamic equilibrium. In static equilibrium is refers to when the object is at rest. This is called static equilibrium. And in chemistry we will study about dynamic equilibrium. Dynamic equilibrium can be classified further into two types, namely physical processes, or we can say physical equilibrium or chemical equilibrium. So, from the question arises, what do you mean by physical equilibrium? If the opposing forces occur in physical processes, then it is called as physical equilibrium. And if the opposing forces occur in chemical processes, then it is called chemical equilibrium. So today we will study about only physical equilibrium. In physical equilibrium, first one is the solid liquid equilibrium. First one is solid liquid equilibrium. Suppose I have taken example of ice cubes and water. This is one beaker, and I have taken some ice cubes as well as water in this beaker. And at the normal room temperature, I have kept this beaker. So what you will observe that there is some changes in water as well as in ice. But a time comes when the melting of when the ice as well as water will become at constant, but means become constant, or we can say they are at equilibrium. It can be said that rate of freezing of water is equilibrium to rate of melting of ice. Next one is the liquid gas equilibrium. Liquid gas equilibrium. In this, we will know that we will take example of, for example, water and U2 mercury, named as manometer. So, liquid gas equilibrium. For example, I will take a beaker, and there is water in this beaker, and I have connected it to a U2 mercury. There is mercury in it, and I have connected it to this beaker. You will observe that firstly, in this beaker, the water as well as the mercury will remain constant. But after some time, you will observe that the concentration of mercury in the right lane will increase, and after some time, it will become constant, and we can say the system is at equilibrium. In this, the rate of evaporation of water is at equilibrium to rate of condensation. Now, third one is the solid gas equilibrium. Solid gas equilibrium. For example, I will take a reaction H2 plus I2 at equilibrium. So I will take I2. So this is supposed to be I2, means iodine. At a time, at room temperature, it will start evaporating. Means it's sublimized into vapor. It is a solid state, but after some time it will start getting evaporating, and its intensity become dark, means dark and dark, and its vapor are of purple color. But a time comes when its vapor becomes, means its intensity becomes constant. So we can say that rate of sublimation is at equilibrium to rate of deposition. Next one is solid gas equilibrium. Oh. Next one is the gas and liquid equilibrium. So in gas and liquid equilibrium, we can take the example of soda water. Suppose we have in our daily life everyone drinks soda water. In soda water, we have take for example bottle. In bottle, you observe that when you open the seal of that bottle, the vapors get means gas releasing gas in liquid. For example, so the gas starts releasing, and at that time the rate of at that time in gas and liquid they will get at equilibrium. So this is all from my side. Thank you. Have a nice day.